the stuff is kind of broken out in different sections, but it's all the same thing. We know definite. An integral is just an antiderivative, right? A definite integral means you have numbers to plug in, so you get a number at the end. An indefinite integral means I don't give you anything to plug in, so what do you have to put on your final answer? Plus c. So that's all we're doing today, indefinite integrals, so we just need that plus c on the end. So let's look at an example. So if I wanted the integral, we know we can do term by term, so what's the antiderivative of 10x to the 4th? Minus 2. Okay, secant squared. What has a derivative of secant squared? And this is the point where last week we were plugging in numbers, but I didn't give you any numbers to plug in because there were no limits here, so we just put plus c. All right. Look at this one. So if I ask for this integral, can I do a product or a quotient rule in reverse? No. Okay, let's think about trig for a minute. Cosine over sine squared. That's the same thing as saying a cosine over a sine and a 1 over a sine. Would you guys agree with that? What is cosine over sine? What is 1 over sine? It's been a while, huh? So sometimes we have to simplify first. Now it's still a product, but do we know of anything that has a derivative of cosecant cotangent? Cosecant. Now remember, all the cos have a negative derivative, so the derivative of cosecant would be negative cosecant cotangent. So to get a positive, we need a negative in front. And then what else do I need? Plus c, because we don't have numbers to plug in. So simplifying first can be helpful. All right. You guys try this one. Do you have an antiderivative of 1/4 x to the 4th minus 3x squared? And this one was not an indefinite integral because I did give you numbers. So we plug those in.
Attention please, the following is a...
Alright, I am actually going to skip example 4. It involves one of those inverse trig functions and I didn't make you memorize those. So I'm going to go to example 5. Before I can do this one, what should we do? Simplify. It's currently a quotient. We know we can't do that. So if we integrate, since it's only one term on the bottom, we can split it up and do each one over that. So 2t squared over t squared would just be 2. Plus t squared, square root of t divided by t squared. What would that leave me with? Because the t squareds cancel. Minus 1 over t squared would be your... All right, so antiderivative, add 1 to the power. So we get 2t plus, this would be t to the 3/2, so it means the 2/3. Okay, this would be t to the negative 1, so it just means a positive in front of it. This is all review, right? We've been doing lots of these. So if I plug in my 9, 292 over 9, I believe. Alright, so indefinite integral is just when there's not numbers plug in plus c. The last couple examples have been definite integrals, so we have numbers to plug in. Hopefully you see the difference between these. If it's definite, you're getting a number answer at the end. If it's indefinite, you just have an expression at the end, so you're left with a function. Any questions there? Okay. Second piece of what we're talking about today is just some applications, some situations. An integral, so we know a derivative is a rate of change. An integral then is the amount of change or the net change. So like an integral, so if we have a position function, we know if we do the derivative, we get the speed, right, the velocity. If you go backwards, it tells you the distance that was traveled in that. So I just have a lot of situations just kind of showing you what these mean. So if V is the volume of water, then the derivative is the rate the water is flowing in, right? So if you integrate that rate, you get the overall change in the water in the reservoir. Or if we have the derivative of so if C is the concentration of a product of a chemical reaction, the reaction rate is the derivative. So if you know the rate of change in your reaction, when you integrate it, you get the overall change in the concentration. If you have the mass of a rod measured from end to end, linear density is the derivative of that. So if we know the linear density and we go backwards, we integrate it, we get the mass between those 2 points. If we know the rate of growth of a population, so we know how the population is changing, when we integrate that, we get the overall change in the population, like the number of people or something, whatever we're looking at there. It could be positive, it could be negative, right? If it's a positive, that means we added people in that time frame. If it was a negative at the end, that would mean we lost people in our population during that time frame. We've talked about the cost function a lot. We know the derivative is marginal cost. If you have marginal cost and you go backwards, you get the overall increase in cost. Not the rate of change, but the actual dollar amount that it did change between those 2 points. We know position. All right, if you integrate velocity, you get the overall change in position. Sometimes that's called displacement between 2 points. All right, last thing I just want to mention, there is a difference between displacement and distance traveled. So if I take a ball and I roll it towards the wall, right, is it just going to stop when it hits the wall? It's probably going to bounce and come back. So if I started it here and it ended, went all the way to the wall, came back, displacement is how far is it from the starting position. Distance traveled would be how far did it go there and back. Does that make sense? So the distance traveled is like the absolute value. You wouldn't subtract off the negative, we have to add the positive. Displacement is just your overall integral where positives and negatives naturally take care of themselves. So I just want to finish with an example of that, and then I'll give you guys time to work today. So we have a particle moving along a line. The velocity is t squared minus t minus 6 in meters per second. First thing I want is the displacement. Then I want distance traveled. So displacement is just our normal integral from 1 to 4. We don't have to worry about if it was going forwards or backwards. It naturally takes care of itself. So my equation was t squared minus t minus 6. So if I do that antiderivative of t squared would be 1/3 t cubed minus antiderivative of t is 1/2 t squared minus 6t. So if you plug in 4 to the third is 64 over 3 minus 16 times 1/2 would be 8.
The same color.
I got -9/2. What does that mean in terms of my displacement? Right, it's basically 4.5 meters behind where it started. Now, does that mean it only moved that 4.5 meters? No. So B, the distance traveled. First, we need to figure out where this is equal to 0. So if we factor, we get 3 and -2. Now, can time be negative? No. So what we are doing, we're still integrating from 1 to 4, but because I want the distance traveled, we're looking at the absolute value of this function. We don't want to subtract off when you went backward. We want to still add that distance in. And so we know the only point in that interval when it equals 0 is 3. So we'll have to go from 1 to 3, and then from 3 to 4. Do you remember doing some of these absolute values last week? If we put in something between 1 and 3, so if I put in like a 2, we get 4 minus 8, so that's a negative. But we know the absolute value makes it positive, so it does the opposite. Can I distribute that negative through? Is that okay? So it'd be a -t squared plus t plus 6. If I put in something between 3 and 4, so if I put in a 4, you get 16 minus 10, that's positive, so the absolute value doesn't change that one. Each, they're the same except signs, and we plug in. So 3 to the third is 27 times -1/3 -9. 7 halves, 18. I'm not going to work this out in my head. I'm going to cheat. And we get 61/6. And this one should be positive at the end. And assuming if your particle moved backwards at all, it will always be bigger than your overall distance, or overall displacement. All right, any questions on those? So I think I'm actually just going to stop here. I'm not going to worry about the last example either. If you look on Classroom, that calendar is the first thing there, but you can go to, the assignment is right below that, section 5.4. And you guys have quite a bit of time to work, ask questions, check your answers. So one thing here, if you look at the first two, they are saying use differentiation to show the integral is correct. So basically, I've already done the integral for you. You're just proving that it's correct. What does differentiation mean? It's asking you to do the derivative. So basically, this is the integral. I'm asking you, do the derivative of this side, and you should get this expression right here. So we're kind of working backwards there. You're doing the derivative of the right to show that you get the left. If I'm doing the derivative of this over here, is sine x minus 1/3. Sine cubed x is the same as sine of x cubed. What's the derivative of sine? Okay, exponent comes down. 1/3 times 3 cancels. Inside stays the same. Subtract 1 from the power, so now it's sine squared, times derivative of the inside. Derivative of sine is cosine. Plus, what's the derivative of constant? 0. If we look, two terms, they both have a cosine. So if you take it out, this is like one of those trig identities we used to do. That leaves you with cosine times 1 minus sine squared. What is 1 minus sine squared? Cosine squared, so you have cosine